Welcome to Mr. V Teaching Math. In this session, we're going to be looking at the volume of a triangular prism. Earlier, we talked about what a prism was. This is an example of a triangular prism. The base and the top are two triangles connected by a series of rectangles. How do we find out what the formula is for calculating the volume of this object? Well, we start with the formula for the area of the base. If you remember some of my earlier videos, you'll remember that there's a whole series of different formulas that can be used to calculate this. My preferred one was this one. If you go back there, you'll hear me talking about how I did not like how sometimes they call the altitude is sometimes called the height. And that's because now we have a three-dimensional object. We're going to times that by height. So here's our formula. Now, it just so happens that there are a couple of different ways you could write this formula, and all of them would be correct. It could be written like this, and it could be written like this. Any one of these will work. I probably use this one most frequently myself, although this one sometimes is also used quite often. At any rate, any one of these three formations of the formula will work for you. Choose the one that you will remember the best. Now, in the work that we're going to be doing in the classroom, there's going to be a couple different kinds of pictures that you're going to see in the work you're working with. Here's an example. That's an example of this object held in about that angle, roughly speaking. However, this particular number, you'll notice there's an awful lot of numbers on it. Those numbers are distractors. You don't need them all. What you need from that picture is you need the measurement here, and they've done that. See this little symbol indicates a right angle. So this line here, that one, which is the 6 meter mark. Then this number over here, you don't need that. What you need is the measurement along this edge right here. How long is that edge? And it just so happens that that's the same as the one way back here, so that's the 8 meter one. You also need to know how tall is this object along these edges here. And you don't need this one. It doesn't mean anything. You don't need that one. It's the 3 meter mark back here. So some of the drawings you have are going to have distractors, and you have to watch out for those. Some of the other drawings you might deal with will be something like this one. Now, unfortunately, I don't have an example. This one is not the right shape because this corner would need to be a 90-degree angle. But if it were a 90-degree angle, it's sitting on about sort of like this. And again, the altitude is going to be easy to figure out because it's the same as this height right here, from this distance right here, from the base to the top. Again, this is a distractor. You don't need that number. You need the base, the altitude, and the height of the object. It might be drawn this way when you've got to think of height being that way. You might also see something that's drawn like this. In that case, we have it's much shorter than what you'd have to cut it down to about there. It's sitting about in that position. Again, there's a bunch of distractors included, information you don't need. You need to know the height of the object. You need to know the base, which is 15 here, and you need to know the altitude. These other 15s over there are not necessary. If I were to calculate this one using one of my formulas, the base of the triangle, because remember this piece is from the triangle part. The base of the triangle is 15. The altitude of the triangle is 13. The height of the prism is 12. I've plugged in all the necessary information, and now I simply have to multiply and divide by 2. Which gives me 1,170. The units from this is centimeters cubed. Some students get startled by how big the numbers are in volume. When you're doing volume, the numbers will be quite large. And that's how to calculate the volume of a triangular